Hi everyone. The goal of this video is to help you understand the 16 coordinates on the unit circle. Okay, so hopefully by next week when I start teaching full lessons, I would expect that you would have at least looked at and hopefully memorized the unit circle. So here I've drawn a circle on the Cartesian graph, which means that all directions hold, right? So right is positive, up is positive, left negative, down negative. It's called a unit circle because the radius has a unit of 1 in all directions. Hopefully you remember, maybe not, it's been a long time, that half a rotation of a circle is exactly pi radians. So radians is the last thing in your notes, so maybe you can look it up. Just quickly, measure of the central angle when the radius and the inscribed arc are equal, that is 1 radian. So conveniently, half the circle is pi radians. And there's our first point. Our second point is 0 or 2 pi. So if you're starting here on the unit circle, you either have not moved or you have completed a full rotation. So there are 16 points to memorize. Let's start with the 4 easy ones. Okay, I don't want to think that you have to memorize these. So if half of the circle is pi, so now you have to set your mind that pi is this semicircle. It would make sense that half of the semicircle is pi over 2. If you're thinking that it's a fourth, that's normal because you're thinking that the whole circle is a full unit. But remember, a full unit is a semicircle because we're using pi. So that's pi over 2. And since this is a unit circle, oh no, I'll talk about that later. Let's first fill in the radians. So that being said, the only one we're missing is when we have pi and then another half. So this is 3 over 2 pi, otherwise known, right? 1.5 pi. Let's fill in these easy coordinates. This point, this is the origin. You've traveled 1 to the right and no change on y. This point, you've gone nowhere on x, 1y. Here we went to the left and we didn't move vertically. Here we didn't move on x and we went down 1. So there are your 4 points. Now we will do the other easy ones. The other easy ones are the fourths. So basically, in the middle of all of these, okay, because the goal, eventually you would take a blank piece of paper and draw your own circle, right? So you can have it as a tool all the time. So this now, it's almost like we're counting in quarters. Okay, you always start here. This is the starting point. The origin is the reference. This is the starting point. So if you're at this point on the unit circle, here I'll just do one arrow. You've completed pi over 4 radians of a turn. And we're just going to keep counting. So this is pi over 4. This is 2 pi over 4, which we don't need because that reduces to pi over 2. So now we're just going to keep going. This is 3 pi over 4 here. This is 4 pi over 4, which we don't need because that reduces to pi. Okay, so it's like some spots are already taken. This is 5 pi over 4. 6 pi over 4, we don't need, reduces to 3 pi over 2. 7 pi over 4. 8 pi over 4, we don't need, reduces to 2 pi. So as I erase, you can I'll just erase, right? If we don't need them, then they shouldn't be there. You can observe that the only quarters that exist or that are there. Oh no, what do I do now? Forgot. Oh well, let's see if this works. Okay. The only quarters that are there are odd. So 1 pi over 4, 3 pi over 4, 5, and 7. You should understand this as the even quarters have been reduced. The quarter points are very easy. It is always the same point. Okay, in another video, I'll show you where these values come from. I should have probably started with that, but I'll do that, I promise. Okay, so I should not have put the negative here. So what I'm trying to show you is that first, we're just putting the same coordinate at each quarter. Right, so very easy. It's only 1 point. Now we're going to adjust the sign. So this is, remember, positive, positive, negative, negative. So positive, positive. We have a negative x here. We have 2 negative coordinates here. And we have positive and negative coordinate here. Okay, so this right now is half the unit circle. I should probably go faster. Okay. Now we will do the thirds. Okay, so I'll use another color so that you can see how I'm changing it. I'm cutting the unit circle into thirds. Okay, obviously not very accurately, but no, that one is wrong. This is not a third here. This is too small to be a third. There. Okay, so if you look at the blue, that's like 1/3 of pi. Okay, so we're not going to write it this way. We're going to write it, that's 2/3 of pi. This is 3/3 of pi, but that's pi, cancels. This is 4/3 of pi. This is 5/3 of pi, and this is 6. Okay, so if you can ignore the black and you can see just the blue now, right? It should look like the fact that pi has been cut into 3 at the top and the second pi has been cut to 3 at the bottom. Again, you just have to memorize 1. The way I memorize it, 3, I remember that 1, 2, 3. So any third will have the same coordinate. And then we just adjust the symbols later. Okay, so I'm going to explain why we have a half. These have to do with right triangles. Well, I'll explain in the next video. And then we just have to adjust our negatives. So in this quadrant, x is always negative. This is the negative quadrant, double negative. And this one here, we have negative y. Okay, so now we have another 4 points. And lastly, we're going to add the last 4 points. I'll use red. These are the sixths. Okay. So here we have pi over 6. Oops, pi over 6. Now, the thing is, the sixths and the thirds overlap. So I'm just going to show you once. Or maybe I'll use dotted lines to show there's a lot of overlap here. But in the end, there is only one extra line in each quadrant. Okay, so try to follow. So this is 1/6. 2/6 reduces to 1/3. No need to do anything. 3/6 reduces to a half. No need to do anything. 3/6. 4/6 reduces to 2/3. Nothing. 5/6. Here we have a spot for 5/6. 6 reduces, we're good. 7/6. Then this, okay, I put that on the wrong side, so I'm gonna just fix it. So then we would have 8/6 here. So I'm just gonna redraw the blue line here. Let me do it right away. Okay, so I'm gonna erase, sorry, just give me a second. This, I drew it the wrong way earlier. So I don't want to make this video any longer than it should be. So just keep in mind that 4π/3 is here, okay? So that's 7/6. That would have been 8/6, already have a spot there. 9/6 is 3/2. 10/6 is reduced to 5/3. We're good. And then lastly, we have 11/6. Okay, so that's why, in case you're wondering, that's why there are only a few of each, because the other ones get reduced. Okay, and I'm almost done. You can ask me questions at any time. I'm hoping a video is easier than just written notes. And then lastly, again, only one coordinate to memorize, and that's the opposite of the other one. So this shouldn't be too difficult. And the way I memorize it is when there's a 6, 3 times 2 is 6. Okay, so when there's a 3 first, it's 1, 2, 3. Well, once you memorize this, the other one is the other option, right? So anything with a 6 has the same coordinate. Okay, I'm sorry this is messy. You should just Google unit circle after, just to see a very clear image. And then we just modify signs. So here we have -x, we have -x, -y, and we have -y. Okay, here it is. So when I refer to the unit circle, if you see me sketch something really quickly, this is what I'm sketching. And really all you have to keep in mind is that the unit circle is a tool that gives you the exact measurement of cosine and sine, so we don't need the calculator, for these 16 angles, right? So for example, if I said, what is the cosine of π/2? 0, right there. What is the sine of 3π/4? Sine is always your y. Okay, so your x is your cosine, your sine is your y. Okay, so this was the first, just so that you can come into the next week or two at least understanding where I'm getting my values. In the next video, I'll show you why these 3 values repeat.